In this video, we're going to work a little bit with properties of logs. In particular, our three main properties. The first is the product to sum property. The second is the quotient to difference property. And finally, the exponent property, which allows us to pull an exponent out front. So we're going to use these three properties in order to solve some expressions involving logarithms. So here's what we have. So we're given log base b of 2 equals x, log base b of 3 equals y, and log base b of 5 equals z. We want to find the following in terms of x and y and z. So what we would like to do is, because we don't have 2 here, we'd like to rewrite this so that it's some formation of 2, 3, and 5. So, well, 12 factors into 4 times 3, or taking it a step further, I can rewrite that as log base b of 2 squared times 3. Now here's why that's going to be useful. My product to sum says I can rewrite this as log base b of 2 squared plus log base b of 3. Now, the log base b of 3 we know it's equal to y, but I don't quite have log base b of 2. I have log base b of 2 squared. But remember, I can pull that exponent out front using that third property of logs we saw. So I can write that as 2 log base b of 2 plus log base b of 3, which equals log base b of 2 is x, so 2 times x plus y. So that's what we want to try and do in each of these. The second one, notice we have division. Now we already have it in terms of 5 and 2, which is good. And properties of log says if we have a quotient inside our log, we can rewrite that as log base b of 5 minus log base b of 2. Log base b of 5 we know is z. Log base b of 2 we know is x, so it simplifies down to z minus x. Log base b of 25. We could rewrite that as log base b of 5 squared, which from our property of logs, that just allows us to pull the exponent out front. That's 2 log base b of 5. Log base b of 5 is z, so 2 times z. Last one. Now again, we don't see the 2, 3, or 5, so let's see what we can do. Well, we know we can write this as log base b of 25 minus log base b of 6. Well, we already did log base b of 25. We know we could write that as 5 squared. Now log base b of 6, I could rewrite as log base b of 3 times 2. So this first one is going to be 2 times log base b of 5 minus, and now I do need to put this in parentheses, log base b of 3 plus log base b of 2. So now I can rewrite this guy in terms of x, y, and z, because it's going to be 2 times z minus the quantity. Log base b of 3 is y. Log base b of 2 is x. And if we want to distribute that negative, we could write it as 2z minus y minus x.